Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, problem 2519. Count the number of K-big indices. In this video, we're going to explain a solution or method based on the use of the heap abstract data type. First, I'll read through the problem statement to digest the requirement, and then we do the analysis and make some connections, and finally we explain the code. First, the problem statement. We are given a zero-indexed integer array called nums and a positive integer k. So here is the definition of index I being k-big. That is, the following two conditions are satisfied. In short, it means that for each index, there are at least k elements to its left, and there are at least k elements to its right. So we are required to return the number of k-big indices. So here are two examples. In example 1, so there are two indices. So the indices are 2 and 3. For example, for index 2, so 2 and 3 are both less than 6. So this is a valid one. And also, we need to add, notice that to the right, it actually has 3 numbers which are smaller than this one. In other words, at least 2. So similarly, we can look at the number 5 corresponding to index 3. So 2 and 3, for example, are less than 5. Similarly, to the right, 2 and 3 are less than 5. So this is also a valid one. So the output is 2. So in example 2, so all the elements in the list are the same. Therefore, the output is 0. So before we do the analysis, let's also look at the constraints. First, the list is not empty, and its length is bounded above by 10 to the power 5. And the element in the list and the key is bounded below by 1, in other words, positive, and in particular positive, and bounded above by the length of the list. So with that said, we are ready to do the analysis. So for this problem, if you have practiced a decent number of Leetcode problem, so this is actually a routine problem or a variant of problem Leetcode 215, or we can regard it as a variant of this problem. So of problem 215. So here the idea is the following. So we try to dynamically maintain the k smallest element if possible. We can do this with the aid of the heap abstract data type. And then when we do the linear scan for each index or each element, so we check if the largest element in the heap is less than the current element we are looking at. So if so, it means that there are at least k elements that are strictly smaller than the current number we are looking at. So we can do the same for checking the right side, right? So this is the main idea. So actually, it's very natural and very simple. So before we write the code, here are some extensions. Actually, we have mentioned that. So you can have a look at Leetcode 215, right? So typically, if you have solved this problem using the heap, you can do the same essentially for this problem. So notice that this problem is marked hard in Leetcode. But if we first solved 215 using heap, this is actually essentially can be solved using the same idea. So you can check out the video for problem 215 in our channel. So yeah, actually the problem 215 is find the kth largest element in an array. So you can also consider the variance right? So find the key largest elements in an array, right? So before we explain the code, here are some comments. First, if we know how to solve Leetcode Problem 215 with the help of the heap abstract data type, then solving this one along the same line of idea is routine, as we mentioned above. So here is an emphasize. So secondly, in this video, we are going to provide a solution using heap abstract data type. So this problem can also be solved using binary search, or you can use the bisect module in Python if you solve it using Python. And actually, it's good to have a try and make ourselves familiar with the common bisect module use cases or use pattern. So in essentially the same line of idea, you can solve this problem using sorted containers like sorted list. So with these comments mentioned, let's look at the code. So for the coding part, actually it's rather routine. So first I'm going to write a hyper function. So it accepts the nums, a list, and a key. Key is like the key in this problem. So here the function will check for each index or the corresponding number if there are at least k elements to its left that are less than the element, say nums I. So this is the function. So the return will be a list of the same length as this nums. So first, let me track the length of this nums list. So we can do this. This is just for convenience. And then we're going to initialize the answer. So the initialization will be like this. So originally false. And then we're going to use a heap. Right. And next we're going to do a linear scan for this nums for I in range n. Right. So what we are going to do is to maintain the previous k smallest elements and check the largest of them. If the largest is less than the current number, if so, it means that to the left of this index there are at least k elements that are strictly less than the current number. So first we want to check if the length of the heap is less than k, right? If this is the case, so we're going to do heap push. So we are going to push into this one the element. So in order to get the largest of the k smallest, so we are going to put the negative, right? So we are doing this. This is the one, and then once we do this, we just continue. Otherwise, so if the length of the heap is greater than or equal to k, so we want to check if nums I is strictly larger than the negative heap 0. The heap 0 will be the smallest element because we put negative thing. So if we put negative, it corresponds to the largest element, right? So if this is the case, so it means that to the left of this index there are at least k elements that are strictly less than the current number. So we are going to set answer I to be true, right? So due to this logic, let me write one more. So once we done this, so what we are going to do? So we want to maintain the k smallest one, right? We are going to do heap q, heap. We can do two operations together. Heap push pop. So we're going to push pop this one. So we do this, right? So push this negative nums I into the heap and pop the smallest one. So this way, so we are going to maintain the smallest k element to the left of the index we are looking at, right? So this way, the heap length is kept at k, right? So then afterwards, we just need to return the answer. So the answer list will contain or encode the information that for each index I, answer I means that if there are at least k elements to the left of I that are smaller than the corresponding number, that is nums I. So this is the main hyperfunction. It's also the main logic. So this is, let's call it step 1. Next, we are going to encode the return logic, or the definition of K-Big index. Right. So for this, first I'm going to get the left, right? So we are going to call this hyperfunction, and then nums and k. And then for check the right, so actually we can reverse this nums list, right? So we can do this, right, equals hyper. So we're going to reverse this guy, and then we're going to do a reverse again. So let's see, reverse the results. If we do the reverse, so here is -1. It means that the right means for each index, if there are at least k elements that are strictly smaller than the corresponding number in that index. And then we just need to return the counting of the index for each index if their Boolean value is true, right? In both positions. So that is return the sum, right? Let's see, return the length. Let's see where I can do this. I for I in range n. If left I is true and right I is true, right? So this is the problem logic. So for now, I guess we are ready to do the test. Let's first do this. And let's do this. So n is length of nums. Yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the cases. So with that said, I guess that's about it for this specific problem, which is also the end of the video. So you are also welcome to check out other videos in our channel. Thank you.